So we're going to look at the vertex first. So we need the second flap on the left. Find your second flap on the left. Okay. Your vertex is the turning point. Okay. Okay. Your vertex is what we call the turning point. This is either a minimum, which is your lowest point, or a maximum, which is your highest point. Okay. It's either a minimum, which is your lowest point, or a maximum, which is your highest point. Okay, enough. Stefan, enough. So, if we open this up and we look at this picture.
I wasn't telling you.
Okay, I will go back in a minute. If we open up and take a look at this picture, where would you label your vertex?
Between the 8 and 6.
Between the 8 and the 6.
Are you talking about on the line, or are you talking about like period?
The graph. Your graph, this U shape. -2, -8. This point right here is your vertex. Okay. That's your turning point. So at this point, take a look at what's happening. Remember, we read a graph from left to right. Okay. So as we read the graph, it's going down, it's going down, it's going down, it's going down, it's going down. When I hit this point, what happens? It turns and it starts going back up, which is why we call this the turning point. Okay. Is this going to be a minimum or a maximum on this graph? A minimum. It's your smallest. Okay. It's your lowest point on the graph. So we can also call this your minimum. Okay. Your vertex here is a minimum. All right. Stefan, there's the definition again. Yo. Also, put on here, let's put on here -2, -8, because that's actually your point of your vertex. So -2, -8. Okay. Now, we do have parabolas that open down. So you will also see quadratic graphs that look like this. And your vertex up here. So my vertex then would be a maximum. Okay. Think about it. It's a hill, the highest point of the hill. Or it's a valley, the lowest point of your valley. Okay. Okay. The tag right underneath a vertex is your roots or zeros. Okay. They may also call this your solutions. Okay. They interchange those words. So they may call it roots, zeros, or they may call it solutions. All these are your x-intercepts. Okay, where it crosses the x-axis. So when they ask for your roots or solutions or zeros, they want to know where does it cross the x-axis.
Why y'all can't give us headache, man? I got a headache.
Because if you happen to be allergic to it and something happens to you, it falls back on us. Remember, your x-intercepts are always some number, comma, 0. Remember, if you're on the x-axis, you're nowhere in your y. You didn't go up or down, so your y is always 0. So, I have 2 roots on this graph. Where are my points? Good. -6, comma 0 is your one on the left-hand side, and +2, comma 0 is the one on the right-hand side. So you've got x-intercepts here, okay? This is your roots, and here. Okay, this is at 2, comma 0, and this is at -6, comma 0. Okay, let's jump to the other side. Let's talk about your axis of symmetry. Okay, let's talk about your axis of symmetry. First off, what does the word symmetry mean? Half and half. Okay, so your axis of symmetry is the vertical line. That makes your graph symmetrical. It cannot. It will always, always be vertical. Okay, because your graphs are always parabolas in this unit because we're talking about quadratics. So your graph will always look like this or like this. If I cut it in half this way, is it symmetrical? No, you can't fold it in half and it land on this way. It's always going to be a vertical line. So your vertical lines are always x equals a number. Please also put here, this is the x value of your vertex. I ran out of room. Okay, this is the x value of your vertex.
What that say in the bottom?
This is the x value of your vertex. Okay, so if we go back to your graph, the line that cuts this in half is this line right here. Okay, notice it goes straight through your vertex. What number on the x-axis did we go through? -2. Your vertex was -2, -8. Okay, so this is your axis of symmetry. And it's at x equals -2. Okay, this is your axis of symmetry, and this is x equals -2. Please note, when you write your axis of symmetry, because it is a line, if you just give me -2, I'm marking it wrong. It needs to be x equals, so please get into the habit of always writing x equals for your axis of symmetry. Okay. It's not a point, it is a line. One more, and then we get into the stuff that you hate, because for some reason domain and range goes woo all over the place for you guys. Okay, so you think it's easy? The last one is your y-intercept. Well, if your x-intercept is where it crosses the x, what's your y-intercept?
Cross the Y.
Where it crosses the y. So where the graph crosses the y-axis. Okay, and this is always going to be 0, some number. Okay, remember, if you're on the y-axis, your x value is always 0.
Are we going around the classroom?
Mm-hmm.
Oh, I love that activity.
I'm trying to find a bunch of fun activities for next week with factoring too. I'm working on it.
Oh, I always want to go to Disneyland. Let's do that.
You are going to save a penguin next week, though.
I always want to do something.
You're going to save a penguin.
It's not a real one.
You're going to factor and save a penguin.
Oh.
Okay. Where is my y-intercept on this graph? -5. It crosses your y-axis here. So here's your y-intercept. Okay. This is 0, -5. The last thing we need to do is domain and range.
Don't step on my domain before you get hit on the range.
Pass it around, grab a highlighter. Pass it around, grab a highlighter.
What time do we get out of here?
12 o'clock.
12 o'clock.
Well,
Oh my God.
bro,
Okay.
Oh,
We got to. We gotta go to third one.
You want the third one?
There's so many ways.
Okay. Everybody should be getting a highlighter. We're passing these around. Everybody needs a highlighter. I don't care what color. Everybody just needs a highlighter.
Pass it around, Daniel. Dang, take one, pass it down.
I like this one.
Okay, bro.
Wait, can I get one?
Think of your mom.
It's not that serious.
Right,
I got you. Right.
They don't smell. They're not smelling markers. They're not smelling markers.
I like smelling Sharpies.
Bray gonna get them, y'all.
Okay.
Oh, that's really
Okay. What I want you to do with your highlighter is I want you to go to your graph and I want you to highlight all of the area that your graph covers. Okay. So my graph doesn't go any lower than this point. So I'm not going to highlight any lower than here. Okay. How far does your graph go to the left? Is it ever going to stop? No. Look at the arrows on your top of your graphs. This means that it goes up and to the left and never stops and up and to the right and never stops. So this graph will cover this entire area.
So do that with the bro.
Okay? Do that with your highlighter. Your graph will cover this entire area.
So we do that with the Sharpie. You color it in.
With your highlighter.
Yeah, I know. It's solid. Color it in like that.
Alright.
Yes.
Make sure.
Yes.
I'm about to get a little
I know I'm wrong. I'm
messy.
not doing this
You
again.
gotta get a little messy.
Bolts.
Remember, don't go any lower than -8.
Okay,
Your graph doesn't go any smaller than that.
You said it.
Your graph stops here. It doesn't go any lower than -8.
No. Fine, what?
Nice.
Bro, we really don't care.
Today.
Oh, I'm fighting
Tell
it.
us how I said we do
Yeah, she said I go that way. I just can't with her.
Okay, so the first thing we need to talk about is your domain. Okay? The first thing we need to talk about is your domain. That's the top left. Okay? So, your definition for domain. The set of all x values. The set of all x values. So, what you're telling me when you tell me your domain is the x values that you can find on your graph. Okay? Okay. On this graph, if I tell you x is 1, what is your y value? If I tell you x is 1, what are you going to tell me your y value is if x is 1? Your graph covers right here. When x is 1, so you would find your 1 and find where your graph is. Your graph is down here.
Okay.
3.
So -3. If I tell you x is -3, what is your y value?
7.
-7. Okay. So is there an x value that I can tell you that you're not going to be able to find a point?
It's like off.
If it's off the line, yes. But in all reality, if this is going to continue, is there any x value I can't use?
Yeah.
Look at how your graph's moving. You're fine. Look at how your graph's moving. Your graph's going up and to the left, up and to the left. This side's going up and to the right, up and to the right. Am I ever going to stop going to the left or to the right? No. So all of your x values will work for your domain. Okay? This is with every quadratic. If they ever ask you for the domain of a quadratic, unless there are restrictions, your domain, x equals all real numbers. Okay? Your quadratics will never stop going to the left or to the right. So your domain will always be all real numbers. We have imaginary numbers, and we're actually going to talk about them in the next unit. That's what we mean by real. We have an imaginary number I. Yes, and it is a number, and it's I.
How was that?
Welcome to math.
This one like that.
I don't
It
get
hurt my
how you
head.
found- I don't get how you found Y from. I'm bored. Like how you
I don't
found Y.
know how to count and multiply.
Because when x is 4, y is -5.
So you go as far as the thingy goes.
Technically, you can find like -10. We just can't because you can't see that much of the picture. Does that make sense? Okay. All right. The last thing we need to talk about is your range. This is the set of all y values.
No.
These are all real numbers.
Okay. No.
These are fake
This one's going to be, no, they're not fake numbers either. Okay. Take a look at this graph. How low does this graph go? -8. So it covers everything from -8 and up, right? That's everything you shaded in your highlighter from -8 up. So your range on this graph is y is greater than or equal to -8. Okay, it never goes below -8. Are you staying or are you going home?
I'm going home. I'm out tomorrow too.
So good. Wait, where'd she go?
Yeah, I got 3 in my kidney
They are.
and a cyst on my right ovary. I don't know what it is.
Let me know if you need anything.
Yeah.
Okay, so this is the set of all y values. You will always have something. It's either going to be y is greater than or equal to a number, or y is less than or equal to a number. Okay, think about it. If you have an upside down parabola, it's going to be y is less than or equal to a number because that's your highest point. Okay, if you have a right side up parabola, it's y is greater than or equal to that number. Questions?
She wanted to know if y'all was two sisters.
No.
You disrespect.
They say that about Miss Horder, myself, and Miss Love. And when Miss Young used to teach here, I got Miss Young all the time too. Okay, this is going to glue in on page 36, ladies and gents.
Can we take a quick?
You right, though. You right.
Where?
Simple that dude. That girl.
Yes, that was
Okay, we're going to glue in your homework assignment before I let you loose to do this around the room. Okay, you're probably not going to finish the around the room today, so when you're done with, please stop talking. You are probably not going to finish with your around the room today. So you're going to hold on to it. And what you do not finish, once you're done with your ACT problem tomorrow in your warm-up, you're going to finish it before we get started on tomorrow's stuff. Okay, so on page 36, you're gluing in quadratic functions. On page 37, okay, you're going to take this piece and you're going to cut out each individual graph. This is your last cutting for today. You don't need to keep the numbers on it if you would like to cut them off. That's not a big deal. Actually, I think we might just wait and do the around the room tomorrow.
Please.
You don't feel like getting up today?
I mean, that's every day, but I mean, today.
Yeah. Today I don't feel like eating. I feel like a Monday. Monday was funny. Like today going by sleep. I don't know why. Boy. You gotta bring that back up. I don't even know.
No, 3.
Oh man, I ain't never know. Like, where is Friday at?
So this one thing takes up the whole thing?
Yes, sir.
I said Thomas, what do you get first? You cut these out individually or like what? Okay.
You're going to cut out all of these individually. Okay, you need to leave yourself space. Okay, so before you glue them in, let me get mine set up so you know exactly where they're going. What you're gonna do for homework tonight?
Bro, homework for goats.
I guess you're a goat. I mean, you said homework's for goats. You got homework, so I guess you're a goat.
Yeah,
I'm not a goat. I don't like homework.
I'm the greatest of all time.
You're the greatest goat of all time.
Yes.
Rock on, friend.
Alright. Home yeah. Goats.
Oh man, I must say.
We're goats. No Curry, no Jordan, so-called LeBron. Right. That's what I said. Yes.
Okay, before you glue these in, you need to make sure that you have room for all of these. Okay, for each graph, you are going to find the key features. So you're going to need to find your vertex. You're going to need to find your roots, your axis of symmetry, your y-intercept, your domain, and your range. So underneath the first three pictures when you glue them in, make sure you leave yourself 6 spaces to put all of the things.
Are they supposed to be in numbered order?
It does not matter what order you put them in. You're okay. It does not matter what order you put them in. No, you're all right. I cut all the numbers off and just glued mine in wherever. Huh? A of S, axis of symmetry.
Yeah, that's that Omega.
It don't matter what order.
Which one was it?
I don't know which one. Basically, I heard like 2 of them.